In this lesson, we're going to review functions, and we're going to start by simply using function notation. In number one, we use function notation and substitute values and expressions into a function. In 2 and 3, again, we practice using function notation by forming what we call difference quotients, and we'll see the significance of a difference quotient in section 3.1. So we're practicing for that. And then we're going to find the domain of a function, and then we're going to practice using a piecewise defined function just to find some values. And finally, in number 8, we're going to practice using function notation with two functions and find the composite functions. Okay, so let's start. We'll start with number 1. All right, we do have here some suggested textbook exercises, but in these lessons we'll be doing the preparatory exercises, which are preparation for the homework exercises. Okay, so let's start with number 1. Okay, let me just get a little bit of scrap over here, and we'll begin. Okay, so here we have function f of x, 5 minus x squared, and we're just going to form f of 3. Which simply means substitute in 3 for x. All right, so here's our function. I'm going to write, instead of x squared, I'm going to write parentheses squared, and then I'll substitute in the 3. I'll put the 3 right in the parentheses. All right, so we're forming the difference, 5 minus 3 squared, 5 minus 9, which is minus 4. All right, now we're going to evaluate the function f of x at the x value minus 2, or substitute in minus 2. Again, the same way. I will write 5 minus x squared, and instead of x, I put a set of parentheses. So then I have a place to put the minus 2 right in the parentheses. I like doing that, so especially when we're substituting in negative numbers, so that we don't make any mistakes with the signs. So first we're going to square minus 2, so that'll be 4. So we have 5 minus 4, and that's equal to 1. Okay, then we're going to form f of 2a, substituting 2a in for x. So again, 5 minus parentheses squared, and put the 2a right in the set of parentheses. Okay, let's square that out. So we have 5 minus 4a squared, and that's it. All right, and now we're going to form f of 3 plus h. Okay, again, 5 minus parentheses squared, and we'll put the 3 plus h right in here. All right, now it's important when we square out the 3 plus h, keep it in parentheses. We don't want to make a mistake with our signs when we open up parentheses. This subtraction symbol applies to this entire term. So now let's square out 3 plus h, and we have 9. And then for the middle term, we're going to have 3h plus 3h, so that's 6h plus 6h. That's the outer plus inner. And then h times h, that's h squared. Okay, so we opened up parentheses. That is, we squared out the 3 plus h. And now we're ready to open this set of parentheses, subtracting the entire term. Don't forget to apply that subtraction symbol, or that negative symbol, to all 3 terms. You can think of it as distributing the negative. So we have 5 minus 9 minus 6h minus h squared. It's sort of like, another way of thinking of it is it's like we're multiplying through by minus 1. All right, we just have these two like terms, 5 minus 9, so we have minus 4 minus 6h minus h squared. And finally, in the last step, we want to form this difference quotient. We already have the pieces. We formed f of 3 plus h, and we figured out that f of 3 is equal to minus 4, so we're just going to put all the pieces in and simplify. Okay, so let me rewrite this. That's f of 3 plus h minus f of 3 over h. So this is f of 3 plus h, so I'm going to put that here. All right, let's say I put it in parentheses. And then in another set of parentheses, I'm going to put f of 3, that's minus 4. I'm going to put that right here. And then we have h in the denominator. We're just going to simplify this, opening up parentheses. Let's do that. So we can just drop the first set of parentheses. So that's minus 4 minus 6h minus h squared. And here we have subtract negative 4, that's plus 4 over h. And we see that these two cancel, minus 4 plus 4, so we're left with minus 6h minus h squared over h. And notice that both terms in the numerator contain h, so we can divide by this h in the denominator, and we get term by term, minus 6h divided by h, that's minus 6. And divide the second term, and we have minus h. And that's it. That's simplified. In number 2, we're forming the difference quotient for a function f of x equal 1 over x. All right, so let's do that. So we have f of 2 plus h minus f of 2 over h. Okay, so we're substituting in 2 plus h into 1 over x, so that's 1 over 2 plus h. Now substitute 2 into 1 over x, so that would just be 1/2 over h. Now this simplifies a little bit if we combine the fractions in the numerator. So here we're going to find the common denominator. The common denominator is just the product of the two denominators. All right, so that's 2 times 2 plus h. Okay, so in this numerator we have 2, and in this one we have 2 plus h. And now we're just going to subtract those fractions. Be careful with signs when we subtract. This subtraction symbol applies to the 2 and to the h. We're subtracting both. So it's as if we're multiplying through by the negative symbol, or think of it as multiplying through by minus 1. So that would be 2 minus 2 minus h. So in the numerator here, we're left with minus h. Okay, so now our simplification comes in. We can cancel this h in the denominator with this h in the numerator. And after doing that, we're left with just a minus 1 on top and 2 times 2 plus h in the denominator. So again, what we did here is we just did this canceling right here, this minus h, this h in the denominator with this minus h in the numerator, and so that's why we were left with minus 1 in the numerator. In number 3, we have another difference quotient to form. this one involving f of x is equal to the square root of x. All right, so let's form that difference quotient. And we want to form it and then simplify. Here we have the square root of 4. All right, that's equal to 2. Now, usually in order to simplify, we want to end up dividing or canceling an h from the numerator and denominator, like we did in the previous examples. Now, we don't see how we can pull out an h from this numerator, but very often when we have a fraction that involves radicals, where we have two terms in the numerator like this, very often we simplify by multiplying top and bottom by the conjugate of the radical expression. So the conjugate of this numerator, square root of 4 plus h minus 2, would be the same thing, except we replace the subtraction symbol by an addition symbol, and that's what we mean by the conjugate. In general, the conjugate of a plus b is a minus b. Or the opposite is true too. The conjugate of a minus b is a plus b. So when we have a subtraction, the conjugate would be the same thing with an addition. All right, so let's do that here. We're going to multiply by the conjugate, and that's just a trick that is used to manipulate these type of radical expressions. And here we're multiplying in the numerator expressions of the form a plus b times a minus b. And remember, what results then is what we call a difference of two squares. When we do this FOIL multiplication, the outer plus inner cancel, are opposites of one another and cancel out. All right, so let's do the FOIL multiplication, multiplying these two numerators. Okay, first times first. This radical times this radical is 4 plus h. That's the product. The outer is 2 times radical 4 plus h, and the inner is minus 2 times radical 4 plus h. So those cancel out. That's why we're doing this type of multiplication. And then when we multiply last times last, we get minus 4. When we multiply conjugates of this type, the radical terms cancel out, and that's very often why we do these, why we multiply by conjugates, to get the radical terms to cancel out. All right, and in the denominator we have to multiply as well, and let's not multiply through, let's just write h times the square root 4 plus h plus 2. After all, we want to cancel an h from the numerator and denominator, so keep the h out side here of the parentheses. Don't multiply through. Notice this 4 and minus 4 cancel. So we're left with just h in the numerator. So there's that h popping out that we were kind of looking for. And it's going to cancel with this h in the denominator. So we do the canceling, left with 1 in the numerator. And here's the simplified difference quotient. 1 divided by square root 4 plus h plus 2.